Hello, we're team number 4 and we're going to present our math video. Our problem is the Doppler effect and the team members are Regina Alvarez, Doddoli, and me, Alondra Sanchez. In this project, we will review some rational and polynomial functions. With our knowledge gained from these two topics, we will find the result to this problem mentioned before.
Fetch back the time they have stolen from us.
As a train moves toward an observer, the pitch of its whistle sounds higher to the observer than it would if the train were at rest. Because the crests of the sound waves are compressed closer together, this phenomenon is called the Doppler effect. The observed pitch p is a function of the speed v of the train and is given by p of v is equal to po multiplied by so over so minus v, where po is the actual pitch of the whistle at the source and so is equal to 332 miles per second is the speed of the sound in the air. Suppose that the train has a whistle pitched at po 440 Hz. Graph the function y is equal to p of v using a graphing device. How can the vertical asymptote of this function be interpreted physically?
Okay, so now we're going with the flowchart. To start, first we have to analyze the problem. After this, we have to use the rational functions formula to solve the issue. Then you ask the question, did it solve the problem? If it didn't solve the problem, you go to the start and repeat these steps again. If it solved the problem, you have to make the graph. Then review your answers, and finally you have your result.
So that I'll never feel alone again.
For this specific mathematical problem, we didn't need a mathematical procedure. We just needed to substitute the formula. The formula is PV is equal to PO times SO over SV minus V, where SO is equal to 332 miles per second and PO is equal to 440 Hz. To graph the problem, we use the program Wolfram Alpha. Now for the procedure, we first started substituting with the main formula given.
Paradise, shouldn't talk about it, shouldn't talk about it. Like this before, we don't talk about it, that's all we do.
Okay, the mathematical model or solution is when the source of sound wave, in this case is the train, is approaching, the sound of its horn is heard at a high pitch and is heard at a low pitch when it goes away. When the train is right beside you, the pitch is exactly at 440 Hz. So the pitch will gradually decrease from above 440 Hz during the approaching.
This is what the program gives us for the graph. In here, it shows that plot is equal y equal 440 times 332 divided by 332 minus x. In here, it shows how this point reaches to this one to this one, and in the same way from this point to this and this one to this point. And that is how the graph looks like. To carry this project, we use rational functions in order to solve the problem. The Doppler effect, at first, we had to study our issue, and after realizing what the Doppler effect was, we started with our questions. Our objective was accomplished. We concluded that when the source of sound, in this case the train, approaches to the established area, then the sound will have a high pitch, and as the train moves away, the sound will have a lower pitch sound. With the graphs of a specific procedure, we realized that the source of the sound were besides you when the pitch will be exactly 440 Hz. Gradually decreases from this unit. To successfully find the graph, we use Wolfram alpha. Rational functions can be very useful to represent a real-life situation, and also to find answers to daily problems, like this relationship between speed and time. It will also focus in the graphic between behavior near the x values that are excluded from the domain. Thank you, Edgar, for being the best teacher ever and showing us what real math looks like.